In this question, we want to determine the minimum amount of material needed to make a cylindrical can with a given volume. Well, we know that volume is equal to pi r squared h. Since the volume is given to be 100, we can state, rearranging our equation, that h is 100 over pi r squared. The surface area of a cylinder is two circles up top plus length times width of the rectangular surface. A cylinder has a rectangular side. It's just bent around in a circle. So the surface area of a cylinder is given by this expression right here. We like to have everything in terms of only one variable, so our expression from h from earlier comes in handy at this point, and we can see that the area of this particular can with respect to r is given by this expression, and clearly r has to be greater than 0. Well, we have an expression now for area. We can take the derivative of that and set it equal to 0. And that would mean that 4 pi r is 200 over r squared, which would mean that r was the cubed root of 200 over 4 pi, which is approximately 2.515. Now, theoretically, the radius of the can could be infinitely small, and theoretically it could also be infinitely large and still have a volume of 100. It could just be really, really flat. So we take the limit as r goes to 0 of our volume expression, and that's infinity. And we take of our surface area expression, and that's infinity. And we take the limit as r goes to infinity of our surface expression, of our surface area expression, and we get infinity there as well. So those are not going to be the minimum surface areas. When we let the radius be approximately 2.515, we get a surface area of approximately 119.3. So the minimum amount of material needed to make that can is approximately 119.3 centimeters squared.